Alrighty, this is Geometry, Note Section 3.1, and in this chapter, we're going to be studying transversals and the role that transversals play when you have parallel lines. This first section, we just got to figure out what a transversal is, and we got to figure out all different types of special types of angle pairs. Parallel lines, definition. Skew lines, definition. Let's compare and contrast these two definitions. Parallel lines are lines that never intersect. Skew lines are lines that never intersect. So that's the same. So what's different about these definitions? Parallel lines are two lines that are coplanar. Skew lines are two non-coplanar lines. Let's look at the difference between those in our picture down here. Line AD and line BC are parallel because they would never touch and they're on the same plane. However, if I were to take line AD, which is highlighted, and line BF, they would never touch, but those are skew because they're not in the same plane. BF is vertical and it's in the foreground. Line AD is horizontal and it's kind of like it's in the background. So I'm going to name for you, first of all, the symbol for parallel is two little slanted segments. Excuse me. So if I name from this picture that we see down here a line, such as line AD, can you name lines that are parallel to it? So line AD, parallel to line BC, also parallel to line EF, also parallel to line FG. Now it's true that all four of those lines aren't in the same plane. But if you take any pair of lines that I named, you could draw a plane that's through them. Some students think, well, how could there be a plane that goes through AD and FG? Well, if I took and had a plane that came in here at a diagonal, like so, and cut through this, hopefully you can see that you could have a plane that's like that goes through that diagonal. You got to use your imagination a little bit, and if you can't, like physically look at things in your room and like use a sheet of paper as an imaginary plane. Skew lines, two non-collinear lines that never intersect, such as, let's take line DH. They don't have a symbol for skew. That's this vertical line in the background. How about this horizontal line in the foreground? There's skew. They would never touch, and there is no plane that contains them. Say we could do line AE. That's here. And we could do line BC. Parallel planes, two planes that never intersect. So in this picture, and again, a good example of that would be this top yellowish plane and the bottom yellowish plane. So this is a box, the top of the box and the bottom of the box. You could also say the left side of the box and the right side of the box are parallel planes. The front of the box and the back of the box are parallel planes. We'll just name one pair. Plane ABC. When you name a plane, remember, you have to use three non-collinear points. And we use the symbol for parallel to plane, the bottom of this box, plane EFG. Transversal. Now this is important. Now we're getting into the nitty-gritty of what we're going to be doing in this chapter. A transversal is a line that intersects two or more lines in different places. So in this picture, technically any of these lines are transversals, because if I were to extend these lines, each line intersects at least two lines. But just looking at the parts of intersection that we can see, T would be our transversal. T is our transversal because T is intersecting two or more lines at different places. It's intersecting L here at angles 1, 2, 3, and 4. It's intersecting angle M at angles 5, 6, 7, and 8. Now, using this as a transversal, in between the two lines that it's transversing, that's called the interior, and outside the two lines that it's intersecting, it's called the exterior. Those are going to be important as we continue. So here are some special pairs of angles. Alternate interior angles. When a transversal intersects two lines, so here's our transversal, here's our two lines. These pair of angles, these meaning alternate interior angles, are on opposite sides of the transversal and between the non-transversal lines. So that means angles 2 and 6. They are between the non-transversal lines, they're on the interior, and they alternate from one side of the transversal to the other. So angle 2 and angle 6 are alternate interior angles. Similarly, angles 3 and 7 are alternate interior angles. Let's look at the next pair of type of interior angles called the consecutive interior angles, also known as same side interior angles. When a transversal intersects two lines, same way as the other one starts, these pair of angles, consecutive interior angles, are on the same side of the transversal and between the non-transversal lines. So, consecutive interior angles would be angles 2 and 3. They're on the same side and they're on the interior. It's a pair of consecutive interior angles. Similarly, angles 7 and 6 are a pair of consecutive interior angles, also known as same side interior. Corresponding, we'll get to that in a second. Alternate exterior angles. So if you understand alternate interior, it's very similar. It's two angles on the outside of the non-transversal lines, and they alternate from one side of the transversal to the other. So angle 1 and angle 5. Also angle 4 and angle 8. Consecutive exterior angles, just like consecutive interior angles, they're on the exterior and they're on the same side of the transversal. So angle 1 and angle 4, angle 5 and angle 8. Excuse me, I skipped one of these. Corresponding angles. When a transversal intersects two lines, these pair of angles are in the same position but a different intersection. So let me try to illustrate this. If I were to take this non-transversal and slide it down here with this other transversal, notice how angles 1 and 3 are overlapping, 2 and 4 are overlapping, 6 and 8 are overlapping, and 7 and 5 are overlapping. Each pair of those overlapping angles, those are corresponding angles. So 1 corresponds to 3, 2 corresponds to 4, 8 corresponds to 6, and 5 corresponds to 7. Whoops. You have to know what these angles are called. There is no way around it. You cannot be successful in this chapter unless you know what each of these special pairs of angles are called. So let's see if we understand this by answering some of these questions. Using the figure on the right, name as many parts as possible. Parallel segments. Well, if I start with this vertical segment AB, it's going to be parallel to segment EF, DC, and HG. If I were to name, we're not going to, it says name as many as possible. We don't have time for that. Let's name another group. So if I take all the horizontal ones, we got segment EH, AD, FG, and BC. And then we could also name another group of 4, these ones that are on a diagonal. We're not going to name all those. So let's just do the horizontal ones. Don't just write these down. Look at the figure when you're done writing this down and confirm that those are parallel to each other. Number 2 says parallel lines. Now this question's in here intentionally because students look at this and they say, well, there's no lines here. They're just segments. That's true, that there explicitly are segments, but you can take any of these segments and extend them and they become lines. So for that reason, I'm just basically saying it's the same answers that we had here, but instead of segments, they're lines. Same answers. They're just lines because the question asked for lines, didn't ask for segments. Number 3, skew segments. Just name these by pairs. So for example, line, segment, AE, and DC. There's a pair. No symbol for skew that I'm aware of, so just put a comma between them. Let's name another pair. Let's say segment BC and segment HG. Question 4, skew lines. I won't cheat and use the exact same ones that I just did. So let's say line EF. And we'll say line BC. Let's name one more pair just to make sure we understand this. How about line DH and line EF? Number 5, parallel planes. There's lots we could name here. I'm just going to name the back of this box as a plane. Name a plane with 3 non-collinear points. And I'll name the front of this box as a plane. So plane EHG is parallel to plane ABC. All right, this last set is probably more important than the first set because most people understand those first set of questions pretty well. Using the figure at the right, name 2 pairs of each. So it's specific, name 2 pairs of each. I should have made the directions for the previous one more specific. A pair of alternate interior angles. Well, angle 4 and angle 6 are alternate interior angles. Angles 3 and 5 are alternate interior angles. Pair of alternate exterior angles. Angles 1 and 7 are alternate interior. Angles 2 and 8 are alternate exterior. Pair of consecutive interior angles, angles 3 and 6, angles 4 and 5. Consecutive exterior, angles 2 and 7 are consecutive exterior, angles 1 and 8 are consecutive exterior. Corresponding angles. If you slide these two transversals together, which angles overlap? Angles 1 and 5. So it's just to name two pairs. So there's actually 4 pairs of this. We're just going to name 2 pairs. Angles 3 and 7. Oh, a linear pair. We haven't talked about that today. But things we've learned in the past never goes away here in geometry. So a linear pair is a pair of angles that come together to make a line. That's angles 1 and 2. That's one pair. Now there are 1, 2, 3, 4, and then 4 more. There are 8 linear pairs in this. We're supposed to name 2 pairs. So I'll name 5 and 8. Vertical angles. We haven't talked about that in this section. Vertical angles are 2 non-adjacent angles formed by intersecting lines. So angles 2 and 4 are vertical angles, 1 and 3 are, 5 and 7, 6 and 8. I'm supposed to name 2 pairs. So I'll name angles 1 and 3 and angles 6 and 8. That concludes the notes. Please make sure that you know the names of each of these special angles, because tomorrow we are going to learn a theorem or a postulate about every pair of special angles. So it's extremely important that you know what these are called. Please do the homework as noted on the web.